Hey everybody, we are going to get started with the 2-3 notes. Lesson 2-3 is all about linear functions. So a linear function is one of the families of functions we talked about in chapter 1. And you guys should be familiar with linear functions and what they look like. We know that the graph makes a line. It's a straight line. We've talked about y equals mx plus b. But at the end of the day, what makes a linear function is that it has a constant rate of change. A constant rate of change. Now, we know rate of change by different names. Rate of change is the same thing as the slope, or rise over run, or change in y over change in x. So we know this from graphing lines. As soon as you get one point, you can just follow the same rise over run to get all the rest of the points forever and ever. So let's say that I'm given a table. So example 1. I have a table, x, f of x, and we go 4 numbers, 0, 2, 4, 6, and -1, 2, 5, and 8. And the question that we're asking is this a linear function? Well, the rule is that a linear function has to have a constant rate of change, aka a slope, a rise over run, or a change in y over change in x. So let's start here. Remember, f of x is really y, right? F of x and y are the same thing. So is our change in y divided by change in x the same? Well, my change in y is plus 3, plus 3, plus 3. What's my change in x? Plus 2. From 2 to 4 is plus 2. And from 4 to 6 is plus 2. So my rate of change, I'm going to just simplify it to ROC. Rate of change is the change in y over the change in x, which is 3 over 2. And it's 3 over 2 for every change. So yes, this is a linear function. This is a linear function. All right, let's try another one. X, f of x. We have -1, 2, 5, 8, 0, 1, 3, 6. So now we check. What's my change in x? From -1 to 2, it's adding 3, again adding 3, and again adding 3. And what's happening here? Plus 1, then plus 2, then plus 3. So here we would have a rate of change of 1 over 3. Then it changes to 2 over 3. And then it changes to 3 over 3. So since it's not a constant rate of change, this is not a linear function. Not a linear function. All right. Let's try some graphing. graph a line with slope of 2/3 that goes through the point 1, 1. Graph a line with slope of 2/3 that goes through 1, 1. Now, this isn't in slope-intercept form, but that's okay. We can still graph it, and we're going to do that. So let me set up my axes here. 1, 2, 3, 4, 5. Remember, you want to try to keep them, equal, so they're not all different sizes. So I know that the line goes through the point 1, 1. So I'm going to plot the point 1, 1, and then I know that I have a slope of 2/3. Well, if I have a slope of 2/3, that means that my rise over run is 2/3 always. So that means I can just go from here, even though it's not the y-intercept, that's okay. I can go up 2 over 3. And I can do a couple points this way, down 2, back 3. And then I have my line, and I can connect just like that. All right, let's see. Let's say we have a line. So graph a line with a slope of 1/4. Negative 1/4 that goes through the point -2, 3. All right, here's what I'd like you to do. I would like you to pause the video and try to graph this one on your own. So pause the video and graph this one on your own for me. All right. Hopefully your line looks a little something like this. Here's my point, -2, 3. And from there, we go down 1 to the right 4. And we can continue that pattern in both directions. All right. Let's talk about intercepts. X-intercept and y-intercept. Now, I think you guys know what it means, right? The y-intercept is where the graph crosses the y-axis, and the x-intercept is where the line crosses the x-axis. So where line crosses the x-axis, and the y-intercept is where the line crosses the y-axis. But here's what I want you to think about for a second. If we're on the x-axis, pick any point on the x-axis. So let's just say, for example, I pick this point right here. What are the coordinates of that point? 4, 0, right? How about this one here? This is -2, 0. This one here, -5, 0. What do all of these points have in common besides the fact that they're on the x-axis? Well, any point that's on the x-axis has a y-coordinate of 0. So the x-intercept is where the line crosses the x-axis, and it is also where y equals 0. Y equals 0 on the x-axis. Now, let's talk about the y-intercept. If you pick any point on the y-axis, let's say we pick this one here. That point is 0, comma, negative 3. Can you guys see where this is going? How about this one here? This one is 0, comma, 4. So any point on the y-axis is where x equals 0. And that's going to come in handy for us here in a second because we are going to try to find the x and y intercepts of these equations. All right, so example 3. We have this equation right here. 2x minus 3y equals 12. And we want to find the intercepts. Find the intercepts. So both the x-intercept and the y-intercept, and then graph. Okay, so here's the rule. To find the x-intercept, we plug in 0 for y. Because remember, on the x-axis, y always equals 0. To find the y-intercept, we're going to plug in 0 for x. That's a 0. Plug in 0 for x. So let's do that. I'm going to plug in 0 for y. And now we're just going to solve for x. What's 3 times 0? That's 0. So I'm really just left with 2x equals 12, which means that x equals 6. So that means my x-intercept is the point 6, comma 0. X is 6 and y is 0. Now let's do the y-intercept. For the y-intercept, we're going to let x be 0. So 2 times 0 is 0, which means I'm left with a negative 3y. And I'm going to divide both sides by negative 3, which means we get y equals negative 4. So that means my y-intercept is 0, negative 4. And now we're going to use these 2 points to graph the equation. Because if I have 2 points, I can make a line. So I have the point 6, 0, 1, 2, 3, 4, 5, 6, and I have the point 0, negative 4. Whoops. Just make the point a little bit bigger there. Good enough. And there's my line. Now, let's just say, for example, I wanted to put this in slope-intercept form. To put it in slope-intercept form, remember that's y equals mx plus b. How would I do that? I would subtract 2x from both sides. And I'd be left with negative 3y equals negative 2x plus 12. And then I would divide everything by negative 3. And a negative over a negative is really a positive. 12 divided by negative 3 is minus 4. Does this give us the same as this? If I graphed this, well, I would start at negative 4. We're off to a good start. Then I would follow the slope and go up to over 3. Boom. Up to over 3. Boom. We get the same thing. Okay. Here's another one. Let's say I have 6x minus 2y equals negative 24. We're going to find the x and y intercepts, just like we did with the first example, and then use those 2 points to graph the line. Okay, so I want you to pause the video and try this one on your own. Find the x and y intercepts. All right, hopefully you were able to find that we are going to have an x-intercept of negative 4 and a y-intercept of 12, and then we can plot those 2 points to find the line. If you got it wrong, go back, pause the video, and look through my work to see what went wrong. If you're still confused, make sure you ask questions when we're back in class. All right, moving on. Let's talk about slope-intercept form. Y equals mx plus b, what we call slope-intercept form. Right, slope-intercept form. M represents the slope or the rate of change. B represents the y-intercept. And these are what we call constants. That means that the numbers that are changing are x and y, but m and b are going to be staying the same. So, example 4. Write the equation in slope-intercept form and graph. So let's say I have 3x minus y equals 5. To get it in slope-intercept form, we need to solve for y. What does that mean to solve for y? It means to get y by itself. I want the only thing, look at slope-intercept form. The only thing on the left-hand side is y. So I want y all by itself. So I'm going to subtract 3x from both sides. That goes away. That's 0x is on the left. I'm left with negative y. These are not like terms. This one doesn't have an x, this one does. They are going to have to stay separate. The other important thing is that you have to remember that this is a negative y. That negative doesn't magically disappear. What that really is a negative 1. Okay? So I'm going to divide everything by negative 1. Negative over negative makes that now a positive y. Same thing here. Negative 3 divided by negative 1 is positive 3x. And that gives me a minus 5. Now that is in slope-intercept form. So there's my slope-intercept form. And now I can graph. Okay, we begin at the y-intercept. The slope is 3, aka 3 over 1. So I'm going to go up 3 over 1. Up 3 over 1. All right, let's try this one. 3x plus 2y equals 4. I'd like you to pause the video and try to solve for y on your own and then graph the line. All right, so hopefully you were able to subtract 3x from both sides. Then we divide everything by 2, which gives you y equals negative 3 over 2x plus 2, and then we can graph it. All right, one last thing, and we're going to talk about horizontal and vertical lines. Horizontal and vertical lines, and I want you to write this down, HA2. HA2. All right. What this means, each letter stands for a word. H is for horizontal. And the O is actually a 0 because the slope of a horizontal line is 0. And Y means that the equation is y equals some number. V stands for vertical. Vertical lines, the U is undefined slope. And the X is for the equation, which is x equals a number. So, for example, let's say I'm told to graph y equals 2. Y equals 2 is y equals a number. That tells me it's going to be a horizontal line. So to graph this, I find where y equals 2, and then I graph a horizontal line. And boom, I'm done. So this is y equals 2. Let's talk about x. Let's say I have x equals negative 3. Well, x equals a number is a vertical line. So I look on the x-axis where x is negative 3, and boom, I draw my vertical line. So this is x equals negative 3. It's very important that you recognize vertical and horizontal lines. I know sometimes it doesn't quite make sense that horizontal would be y and vertical would be x, but that's just the way it is, because if you pick any point on this line, y is going to equal 2. I mean, take this point, for instance. That's the point 0, 2. If you pick any other point, we have 2, 2. Here we have negative 5, 2, and so on. All right, thanks for sticking it through this video. We'll see you next time in class.